Good morning, one and all. Welcome to another session on data mining. This is Dr. Diana here. In the last session, we started understanding uh, of association rules. We started with Unit 2. Today, we will look into some examples of frequent patterns and the mathematical measures that define a frequent pattern. Now, in a frequent pattern, a pattern is represented always with a predecessor and a consequent. This is an example of a pattern. So you have a predecessor, which is the computer, and the consequent, which is an antivirus software. So this defines a pattern in which the buying of computer occurs first and the buying of antivirus occurs next. So you have two events and you have a pattern that defines these events. I try to calculate the probability of occurrence of these events to see whether this pattern will repeat itself in the future. So that is the objective of understanding frequent patterns. That is the objective of analyzing frequent patterns. So here we are trying to see a predecessor and a consequent and to check how much of probability we have for the same pattern to occur in the future. It may be a buying of a computer and an antivirus. It can be buying of a product A and product B, or it can be the attendance of the student and the grade of the student, or it can be application for a loan and sanction of loan. So there are different activities that can be defined as predecessor and consequent. So many of our real world problems are also modeled using a predecessor and a consequent. What happens when I take a decision like that? So we are going to associate some mathematical measures that can help us understand the degree of probability with which it will occur in the future. So these measures are called as support and confidence values. Support is mathematically defined as the ratio of all the transactions under analysis to the number of transactions in which the predecessor and the consequent are present. So if I have 100 transactions in my sales, then I can say that out of 100 transactions, 2 of the transactions had both computer and antivirus software to purchased together. In that case, I can define my support value to be 2%. So 2% of all the entire transactions had both computer and antivirus purchased together. That defines the measure of how many times this pattern repeats in the entire set of transactions. And we can also define another value called as confidence. Confidence is the measure of relative occurrence of these two events. So how much of confidence do I have that the antivirus is also bought every time that the computer is bought? So when I think about that, I can say I can understand that every time a computer is bought, is a virus or antivirus also bought along with it. That defines the confidence of relativity among the predecessor and the consequent. So if the predecessor occurs, I assume that the predecessor has already occurred and see how much confident I can be of the consequent happening after that. That is called as the confidence value. Confidence is measured as the percentage of customers who purchase the computer also bought the antivirus software. So how much of them bought the antivirus software. So that defines the confidence of a pattern. Now, the support and confidence of the pattern, if it is really high, then I can see that this pattern is frequently occurring in the past. Then I can also predict that this same pattern will repeat itself in the future. So I try to predict my future based on my past events and based on the probability of occurrence of certain events. So this is what I try to do when I do a market basket analysis. We will look into an example to see how this support and confidence can be calculated. Now, we started with this example and we have a set of items bought with each transaction uniquely identified with the transaction ID TID. We have got 10, 20, 30 and 40 and 50 as transaction IDs, and we have a list of items that are bought in every transaction. Now in the Venn diagram that's shown below, you can see that the yellow represents the group of customers who buy bread. To see that, I have to count all the transactions which have bread as one of the items bought in that particular transaction. So I can see that transaction ID 10, 20 and 30 have bread bought with them. And in the Venn diagram, I can see that the blue color is represented for all the customers who buy diapers. Now these diapers, I have to check which are the transactions in which diapers are bought. I see that transaction ID 10, 20, 30 and 50 have bought diapers. Now the region in the Venn diagram that is indicated by the combination of both blue and yellow shows the group of customers who have bought both. So when I look at that, I should look into the number of transactions which have both bread and diaper present in them. So count and tell me which are the transactions that have both these items. I have transaction ID, very good, 10, 20 and 30 have both bread and diaper. And I also have a transaction ID 50 in which diaper is present but bread is not available. So only 3 transactions have both bread and diaper together. So that region represents both bread and diaper. Now I try to calculate the support value. Support value is the frequency of occurrence of an item set. An item set means a group of bunch of items that are purchased together. Here my item set is bread and diaper. So I represent it as S of the set bread and diaper is 3, or the support count is the number of transactions in which both these items are present. I have transaction ID 10, I have transaction ID 20 and I have got transaction ID 30 in which both bread and diaper are present. So my support count is going to be 3. Now I am going to find the support value. Support value means the fraction of all, it is more like a probability. So out of total number of transactions, how many transactions have both these together? So support means it is the fraction of all the transactions that contain this item set. So I can write it as S of the set bread and diaper together is 3 out of 5, because I have totally 5 transactions, out of which 3 transactions have both bread and diaper being bought together. I want to now check whether this is a frequent item set or not, whether this is frequently purchased or not. An item set is whose support, so what I do to understand that is, I define something called as a minimum support value or a minimum support threshold. I define a value like that and any combination that has a support value of greater than that, I will consider them as frequently bought. Now, when I have only 5 transactions, I can say if I have minimum 3 transactions, I can call them as frequently bought. If I have 1000 transactions together, then if I have maybe above 500 transactions, if the products are bought together, then it is naturally a frequently occurring pattern. So I can define my support threshold, minimum support threshold, depending on the total number of transactions I have. So for a stationery store, bread and diaper, these are continuously bought products. But imagine I have a company with, say, I do this analysis for Maruti group of cars. I have lots of cars being purchased, and I have a very fine segment car. And some of the accessories that are purchased along with that. For this item set, bread and diaper, I can define 0.5 as or 1/2 as minimum support threshold. Only if at least half of the transactions have both these products bought together, then I would say they are frequent. In the car example, it cannot be so. So in that domain, half of the cars that are being purchased, I can't mention that they are of one kind. So do you get my point? So the minimum support threshold is defined depending on the domain in which the this thing is bought or the algorithm is applied. In a Rolls-Royce car company, if I say a car being bought in one day to be frequent, then there will be no frequent pattern at all. So I allow a window of time and see within 1 week how many cars are bought. So that way I define my minimum support threshold. Now, if my item set's support value is greater than the minimum support threshold, then I call it as frequent item set. So this is the actual way of defining support. Support is the probability that a transaction contains both X and Y. Confidence is the conditional probability. Now, confidence is defined as the support value of A and B to the support value of A. Now, let me calculate here. What is the support of A and B together? In the previous value, you calculated it as 3/5. What is the support value of A? A denotes bread here. How many transactions do we have bread present? We have 3 out of 5 transactions. So the support value of X is also 3/5. I'm sorry, this should have been support value of Y. So we have, when I think of diaper as my predecessor and bread as my consequent, how many of my support values have both bread and diaper together? It is 3. And the support value of Y is how many how many of the transactions have only diaper? It is 4. So I have 3 out of 4 transactions. So that defines my confidence value. So I can define my pattern as, so I can define my pattern as diaper. Every time a diaper is bought, the consequent is going to be bread, and 60 percentage or 3 out of 5 transactions have both diaper and bread together, and out of the number of transactions in which diaper is bought, which is 4, 3 transactions have bread also. Do you understand? So 4 indicates the total number of transactions in which diaper is present, and 3 is the number of transactions in which bread is also purchased along with diaper. So the confidence of that is 75%. Now do you understand the value of support and confidence? Having this in mind, we are going to work out one example. So I've got a list of items and I've got some transaction IDs. Now let me know the support count of each of these items. When I have only one item in the item set, it is called as L1 item set, or the first level of item sets, for which I have only the support count. So I have to count the number of transactions in which pen is present. So I can see that transaction ID 1, transaction ID 3, 4, 6, 9, 10, 11 and 12, they've got the item pen bought. So the support count of pen is going to be 8 in the set of transactions. The same way I can count the number of transactions in which pencil is being bought, eraser, likewise I just count them and see whether they are frequently bought. Pen is a very frequently bought item because it is there in 8 out of the 12 transactions that is being purchased. So this is the support count of L1 item set. Now if I define my support value to be 4, if I define my minimum support threshold as 4, then the value scissors, sharpener, ruler, all of them do not have a minimum support threshold. So I will remove them from calculating and I will use like this. Now I am getting all the possible combinations of pen along with the other values whose support value is greater than the minimum support threshold. Because scissors, sharpener and ruler are not frequently occurring, they can't occur. So I am taking out those and rest of the items I have included here. This defines the frequent set L2. So I define L2 as group of all item sets with 2 items in them. Now find out the support count of each of them. Check the number of transactions in which both pen and pencil are present. I have transaction ID 1, I have transaction ID 4, I have transaction ID 10 and I have transaction ID 12. So I have got 4 transactions in which both pencil and pen are present. Now count in how many transactions pen and eraser are present together. So we have transaction ID 1, transaction ID 3, 4, yeah, that gives me 3 transactions. So likewise I count and find out the support count of all the possible combinations. This I have done for only pen. This pen along with pencil, pen along with eraser, pen along with paper, pen along with glue, pen along with ink are the possible combinations I have identified. For them I have found. Now for pencil I have to do the same. Pencil along with pen, pencil along with eraser, pencil along with paper, pencil with glue, pencil with ink, etc. So this combination also I have to find out. For a combination of two, now I am going to check the confidence value, because if I purchase one item set, I need not go into the relative purchase frequency. But when I purchase two items, I should see the confidence level also. Confidence means out of the total number of transactions in which pen is bought, how many times pencil is also bought together. Okay. How many transactions have pen here? One transaction ID 1, 3, 4, 1, 3, 4, 6, 9, 10, 11 and 12. I've got 8 transactions in which pen is present, and out of that I have got 4 transactions in which pencil is also present. So my confidence value is going to be 4 by 8. And because pen is considered as the predecessor here, all the denominators of the confidence value that have the same predecessor are going to be same. So I have 8 as the total number of transactions in the denominator for confidence values for all these combinations. So for pen and eraser combination, I can see that 8 transactions have pens, out of which 3 transactions have eraser also. When I look into the combination pen and paper, I can identify that out of 8 transactions in which pen is present, I have 1 transaction in which paper is also present. That way I find out the confidence of buying pencil every time a pen is bought. So the same way I can do for pencil. For pencil, the support count value, if you look at the table below, it is 6, which means there are 6 transactions out of 12 in which pencil is bought. Now I am going to check out of those 6 transactions, how many of them have pencil and pen together. So if you count the transaction IDs, transaction ID 1, transaction ID 3, transaction ID 3 doesn't have pen and pencil together. So I have transaction ID 1 that has got pen and pencil together. Transaction ID 4 has got pen and pencil together. Transaction ID 10 has got pen and pencil together, and transaction ID 12 have got pen and pencil together. So I've got 4 different transactions in which both pen and pencil are present. So my support value of pencil pen combination is going to be 4. The same way I can count for all the other combinations. And for the confidence, I see pencil is present in 6 transactions. So my confidence is going to be, the denominator of my confidence for all these combinations is going to be 6. So it is 4 by 6, 2 by 6, 3 by 6, 2 by 6, 1 by 6. These are my L2 item sets for the predecessor pencil. The same way for predecessor eraser I can find, and for predecessor eraser I have just counted and written it there. Confidence is out of 4 because there are 4 transactions in which eraser is present. And I've done the same for paper and all its consequence. The same way I've done for glue, and I've also done for ink. These are the possible combinations. So I've done with them. Now this gives me the set of all L2. With pen as predecessor, I've got some. With pencil as predecessor, I've got some. With eraser as predecessor, I've got some. Likewise, I've listed all the possible values that I've received till now. And their confidence value is also listed here. From this, now I am going to find out how many of them are frequent in nature. Now, if I set my minimum support count to be 2, all the red ones do not satisfy the minimum support value. So, I can see that those combinations are not frequently occurring. So, only the black ones are frequent. So, this set of black ones, all the black fonts that you see, pen and pencil, pencil and pen and eraser, these are frequent L2 item sets with the minimum support value of 2. Are we clear here? Now if I take my minimum support value as 3, then pen and eraser combination will also go away. So likewise, I can take my minimum support value and define my set. Once my set is defined, I have got a set in L2. For L2, now I am going to form L3, who are all possible combinations of L2. So pen, pencil, whichever has got pen as predecessor, I can combine those two. So I have got a pen, pencil, pen, ink combination, in which in both of these transactions I see pen as the predecessor. So I can form an L3 item set with pen as predecessor and pencil and ink as consequence. And I have got 3 transactions with pencil as predecessor. So I can form a combination in which pencil is the predecessor and 2 of the other this thing are consequence. So I can form L3 as pencil as predecessor, pen and eraser as one consequent. Then for the next, pencil is the predecessor, eraser and paper are the consequence. Then I have pencil as the predecessor, pen and paper are consequence. That way I can define my L3 item sets. So this gives me the set of all L3 item sets. Now I have to count the support value of this in the given set of transactions. So these are my transactions. When I count the support value of these, I can see that the support values are listed here. There is only one transaction in which pen, pencil and ink, all 3 of them are present. There are 2 transactions in which pencil, pen and eraser are present. Likewise, I count all the number of transactions in which all the 3 of them are present. That gives me the support value. To calculate the confidence value, I need to check the number of transactions in which the predecessor was present. For the first combination, pen, pencil and ink of L3, the predecessor is pen. So, out of the total number of transactions in which pen was present, I need to look for transactions in which pen, pencil and ink are present, which is one transaction, all 3 are present out of 8 transactions in which pen was present. So that minimum support, that support value I take from L1. So out of 8 transactions in which pen was present, pencil and ink are present in 1 transaction. Likewise, I list. Now if I define that my minimum support value is 2, some of these transactions or some of these combinations will be ruled out. So I can say pencil, pen, eraser is a frequent pattern, and eraser, pen, pencil is a frequent pattern. The same way, but you can say that they are repeated. Eraser, pen, ink is a frequent pattern, and pen, paper, pencil, glue is a frequent pattern. So this is how we calculate or identify frequent patterns from databases. So I hope you are all clear with the idea of frequent pattern generation. So this is the basic methodology. We will look into some specific algorithm in the next session. The algorithm would be called as a priori algorithm. We will look into that in the next session. With this, I will conclude for today's session. All of you stay home, stay safe. Looking forward to having you all in the campus very soon. Take care. Thank you, all of you.